Hello, dear aspirants. This is Dr. Sourav Sir Classes. Our contact number is 98367 93076. Again, I am repeating our number, which is contact number, which is 98367 93076. And our email ID is souravsirclasses@gmail.com. So, if you have any mathematical queries, doubts, or anything, so please feel free to contact on this number. That means you can call on this number or WhatsApp also. Rather, you can drop an email to our email ID, then our team can arrange it out clearing session for you. After that, you can join our regular batches, our one-on-one sessions, and our online classes. So that will be beneficial for your preparation of upcoming examinations like ISI, CMI, TIFR, NVHM, and GATE, NET, etc. So please feel free to contact if you need our help. And for your semester exams also, okay. So now we are going to solve a problem which is appeared in the GATE AI question paper, and the question is telling us that the number of additions and multiplications involved in performing Gaussian elimination on an incross and upper triangular matrix is of the order O of n square, O of n cube, and O of n to the power 4. Okay. So let us see what we can do with this. So we are going to determine the number of additions and multiplications involved in in performing Gaussian elimination on an n-cross and upper triangular matrix. So let's analyze the process step by step. Okay. So now the Gaussian elimination on an upper triangular matrix. So a upper triangular matrix, let us call it U, has all zeros below the main diagonal. That is, we can write that our uij is equals to 0 for all I greater than j. And Gaussian elimination on such a matrix simplifies to back substitution since no elimination steps are needed below the diagonal. So now the back substitution steps start from the last row, that means our nth row, and solve for xn. Now move towards the n minus 1th row. Then we have to solve for xn minus 1 using xn and continue upwards until the first row, and we can achieve our x1. Okay, that means we can do the solving for x1. So now operations count for each row I from n down to 1 division to normalize the pivot if necessary, and substitutions for each j from I plus 1 to n. We perform from I plus 1 to n, we perform one multiplication and one subtraction. Multiplication for, that will be what? For our u, j, xj. And the subtraction to update the right hand side. So now the total operation. So for a row there, for row I, we can say that we are getting n minus I multiplications and our n minus I subtractions. So finally we are getting that. So summing over all rows I equals to n to 1. So the total multiplication and addition is our summation I equals to 1 up to n, summation n minus I, that is equals to summation k from 0 to n minus 1. So that is equals to n into n minus 1 by. Thus the total number of the operations will be our big O of n square. Okay, so the number of additions and the multiplications is of order big O of n square is the correct answer of this question. So the correct answer of this question is our option B. Okay. Hope you understood, guys. Again, I am telling that if you have any other mathematical queries, doubts, or anything, so please feel free to contact on this number. That means you can call on this number or WhatsApp also. Rather, you can drop an email to our email ID. Then our team can arrange it out clearing session for you. After that, you can join our regular batches, our one-on-one sessions, and our online classes. So that should be beneficial for your preparation of upcoming examinations. Okay. Hope you understood, guys. Thank you.